In today's video, I will show you how pyruvate convert to lactate, acetyl-CoA and oxaloacetate. So before doing that, I want to know you that how pyruvate comes. So actually pyruvate comes from the glycolysis process of glucose. So if this is glucose, okay, this is glucose, and uh, by glycolysis we will get that pyruvate, and after pyruvate it will convert like lactate, acetyl-CoA and oxaloacetate. So this acetyl-CoA and oxaloacetate both are part of that citric acid cycle, and this part, this lactate, this actually produced when you are doing like physical exercise or you have insufficient of oxygen, then your body will produce pyruvate to lactate. So doing that, we need lactate dehydrogenase, and also here what will happen, NADase will used and it will produce NAD plus, and these steps are reverse also. So this NAD plus is actually fuel of glycolysis. That's why when you are doing so much or intense exercise, you will fall of ATP and feel like lethargy or something like that. And also here you can see that pyruvate converts to oxaloacetate. So here oxaloacetate is 4 carbon and pyruvate is 3 carbon. So to do that I need bicarbonate here and biotin, and also I need ATP. Here this process, this coenzyme is also known as pyruvate carb carboxylase here. So what will happen here, this ATP will activate that bicarbonate and produce carbon dioxide, but this is activated carbon dioxide. So this is nothing actually, this is activated carbon dioxide, and this activated carbon dioxide later react with biotin, and this biotin will produce a compound like, if I draw like that, and this compound will react with pyruvate, and this pyruvate, this reaction produce oxaloacetate. Here you can see that. So this is how you can convert that pyruvate to oxaloacetate, and you need bicarbonate, biotin and ATP. So here also we produce ADP, and also in that case pyruvate to acetyl-CoA. So here you can see that pyruvate has 3 carbon and it has 2 carbons. So you need to do like pyruvate decarboxylation, or you need to eliminate that carbon dioxide. So this carbon dioxide will be removed from here, and we need a coenzyme like, so I'm sorry, so coenzyme like, and we need to add that reaction, this enzyme, and also here you can see NAD plus will produce NADase. So in another word, NADase equal to 3 ATP. So we are producing 3 ATP here, and actually in glycolysis it will produce 2 pyruvate. So one step of glycolysis, it will produce 2 pyruvate, and 2 pyruvate will produce like 2 cross 3 ATP, that's mean 6 ATP. So here we produce 6 ATP. So in that case, this acetyl-CoA and also the oxaloacetate uh, will react and produce citric acid, citric or citrate acid. So then it will continue that TCA cycle. So I want to inform you that so this pyruvate will produce one of them, acetyl-CoA or oxaloacetate. So in usually it will produce pyruvate to acetyl-CoA because this pyruvate produced in cytoplasm, and this oxaloacetate is in mitochondria. So producing that oxaloacetate is hard. That's why pyruvate will produce acetyl-CoA, and which will input in that TCA cycle and react with oxaloacetate and produce citric acid or citrate, and then citrate to isocitrate, then alpha ketoglutarate, then succinyl CoA, and later we'll get malate to oxaloacetate. This is how citric acid cycle happen, but our main goal is to how pyruvate convert to acetyl CoA and lactate and oxaloacetate. I think you got that, and I think you better got that. And see you soon.